For number 7, we're told that a 53.0 ohm resistor is connected, as in the figure, to an AC generator with alternating EMF 25 volts. What is the amplitude of the resulting alternating current if the frequency of the EMF is 1.14 kHz and 7.61 kHz? Our first value is 53.0 ohms. This is our resistor. So we can say that R is equal to 53 ohms. This is also going to equal XR, which will become relevant in a second. Our alternating EMF is 25 volts, and that's also equal to V of R, which will become relevant with our X of R. In previous problems, we had this formula, I is equal to V of L or X of L, and that was looking at this portion right here. And in another previous problem for 5, we have I is equal to V of C over X of C, which is involved right here. For 7, it's going to be practically the same thing, where we are going to use this formula, I, since we're finding the amplitude, is equal to V of R over X of R. In this instance, X of R is just going to equal R. So if we plug this back in, we can continue on with our formula and see that I is equal to V subscript R over R. Now we can solve for A and B. For A, we have 1.14 kilohertz. That's going to be equivalent to 1.14 times 10 negative cubed kilohertz. For part B, we have 7.61 times 10 negative 3 hertz. If we look back at our formula, we can see that there's only two values that we need to plug in. We don't need to actually look at the frequency. This is frequency. In our previous formulas, we had to find this F value here and this F value here, frequency. However, for 7, when given the resistor actually remains, the resistant remains constant for any different frequency. So it's just going to be one value for A and B. That means that I is just going to equal to 25 volts over 53 ohms. And if we plug this into our calculator, we can see that we get approximately 0.47 amps. This is going to be the answer for both A and B, because regardless of frequency, the current is constant.